Welcome to Koh Young here at Productronica. Delighted to be joined by Harold Eppinger. Nice to see you again, Harold.
Hi.
Okay.
Good.
So, lots to talk about this week on the booth because you've got quite a few new machines. Of course, at the front here you've got your flagship SPI and AOI systems.
Correct.
Still selling well.
Of course,
yep.
that's the high runner for us, yeah.
Okay. But moving further back, we've got some movements into almost towards the semiconductor side with some of the geometries you're doing. Can you talk a bit about that?
That's very simple. We have realized in the past that in Europe the standard components have been used for a long time, and now with the new application, sensors, high-dense application, there's also miniaturization coming to Europe. And there's a merge between the green PCB and the semicon, so the end result is you need a higher resolution with still a good check time, and that's why we are introducing the Meister series, which is about 5 micron resolution, and it can detect very small deposits, very small components, and that's one of the new trends which we are facing in Europe.
So that's the Meister series. Typically, what size of devices are you measuring down to? I know you're doing a 5 micron plus or minus accuracy, but what size of devices? The resolution of the camera. Oh, I see.
And the dimension is about 30 microns pad diameters. That's really small.
Yeah.
It's very hard to see for us old gray guys to see the small deposits, so we need the machine for this. Yeah, it's really getting small.
Right,
yeah.
right. But I mean, there's definitely a demand, things are getting smaller and it's inevitable that you're going to move more into that space.
Yeah, that's clear, and we would like to offer our customers with the existing core technology, which is the same technology we're using for years and it's proven, into these new applications. It's not just about something total new, it's just kind of new application we should cover. And there's a regular PCB production and there's the small size production, and so we have to cover.
So moving around the back of your booth, you've got a few machines from other vendors, printer manufacturers, where they're paired up with your SPI system to show closed loop inspection. You've been doing this for a while, but...
Yeah, it's even more than just the closed loop. In the past we had the closed loop to correct some offsets. In the meantime, the high mix environment of our customers forced them to tune the printing process to get the good results at the end of the day. And the KPO is active communication between the printer and the SPI, and we try to optimize the setting for the first run. So with a few boards in printing, you can really create the optimized setup that you get the best quality in printing process out of your line. And this is fundamental for the next steps. When you put the components on, there will be a better solder joint, there will be a better quality of the board. So, and to prove this, because everybody is talking about Industry 4.0, everybody is talking machine communication, and this is the way it starts in getting in real life. We show here the communication with the printer and some other partners. We will find other machines on the different pick and place manufacturers. Yeah. We are showing the closed loop capability. Yeah. And we are communicating actively predictive maintenance to advise even pick and place machine manufacturers, something wrong here, exchanging a nozzle, finding the real root cause.
The real root cause, okay. That's an interesting area, absolutely. But just moving back to the printer for a minute, because that is where the majority of the defects come from. What parameters are you actually measuring? Apart from paste deposits and paste volumes, are you measuring other information coming off about the squeegee and the...
Let me say, very general, we have all the 3D dimensional aspects of a printed deposit. And taking this out in the height, in the slope, everything, and this is converted with controlling the pressure, the speed, the snap of the key parameter. We try to optimize to the best result. Today's application, we have small deposit, we have big deposit. You have to go for a compromise, and you have to focus what you would like to print, because there's no perfect, but you get the nearly perfect setup to make sure that there is no deviation from what you expect from the board.
I mean, most people would say that the biggest defect that comes off the printer is usually missing paste. Would that correlate with what you're finding?
I would say the missing paste is easy going to fix, so I would say it's not the massive one. Maybe if you have the wrong settings, that might be. But I think it's more important that you have to apply the right volume to get an IPC conform solder joint.
Right.
because the missing one is obvious. It's not there. But if you have 10% less or 20% less, you cannot justify it. But it might be very important for the quality of the board.
So it's a volume. Okay. So I want to turn my attention now to some of the other things you're doing, because you're moving almost a little bit beyond the production line into actual measuring components and devices and pins. So you've got some pin measurement systems, and you've also got some different component measurement systems. Let's start with the pin system.
Yes, our valuable customers, they told us we have a need. We need to measure this kind of banded pins or wrong pin lengths, because this becomes important, and everything was done in 2D with the limitation of the false calls. And especially automotive customers approached us and said, is it possible? And we found a way. Meantime, it becomes a product. The algorithm is used also in the AOI, but there is a process after the regular SMT process. There is ICT, there is functional test, there is programming, there is final assembly. And there is a risk that these pins have been bended, and this pin inspection is making sure that the boards and the connectors, everything is on the right place with the right lengths, that it works out later in the field properly. And this is not just for automotive, it's also a very nice application of the backplane manufacturers with thousands of pins. So it's quite nice application, and it expands our product portfolio out of the pure SMT.
Yes.
And you mentioned the mechanical inspection. We have a machine which is called the open platform machine. We can put it on every application, every conveyor belt, even robot systems. And it goes for mechanical inspection. So it's measuring optically mechanical aspects. So coplanarity of buttons, of connectors, of anything which is assembled.
Right.
Yeah. And this enables also us to go into a non-SMT business, which is still part of the electronic manufacturing process, but it's a front and back end.
So it's any sort of 3D product. Like it could be like a dashboard and this type of thing.
Dashboard, it could be a simple mechanical assembly process, some screws, some heat sink, whatever. It has to be precise. Maybe before you put the PCB into a box, that it has to fit. So that's some critical distance measurement, it's called.
Great. Well, it's great to see how you keep expanding your portfolio, Harold. It's hard to keep up. I'm guessing that's part of the reason why we've got such a massive stand here at Productronica.
Yes, luckily with the cooperation with the show here, we could expand. This is a quite nice booth, and you need a while to get to the end, and and we hope we can survive it. Yeah, it's good. It's really good to be here with the big booth and with all the products.
And it's great. It's great to see all the continued innovation. So thank you for joining us again today.
Thank you. Thank you.